Hello everyone. Okay, so in this video we're looking at the addition, subtraction and multiplication of complex numbers. So last video we were just looking at roots of negative numbers and finding I. This video we're now looking at complex numbers and some operations with them. So what is a complex number? So a complex number consists of a real part and an imaginary part. Complex numbers are usually denoted by Z. So they're usually written like this. Z equals A plus BI, where A is my real part, i.e. it's a real number, and B is my imaginary part. So, for example, Z could equal to 3 minus 2i. That is a complex number. I could have Z is equal to 4 plus root 3i. That is also a complex number. So, when adding or subtracting or multiplying complex numbers, we basically treat the I like we would an X in algebra. So, it's very straightforward. So, let's have a look at this here. So, this is from the 2018 paper. So, let Z1 equal minus 2 plus 3i. Let Z2 equal minus 3 minus 2i, where I is equal to minus I squared equals to minus 1. Find Z3, which is Z1 minus Z2. So I'm going to have minus 2 plus 3i minus negative 3 minus 2i. And again, we're just treating this like we would like an X in algebra. So I'm going to have minus 2 plus 3i minus negative 3, which is going to be plus 3, minus negative 2i, which is plus 2i. Gather like terms. 3i plus 2i is going to be 5i. And then minus 2 plus 3 is 1. And then just to rewrite that in the form A plus BI, Z3 is going to be equal to 1 plus 5i. And that's our answer there. So it's very much the same as algebra. Then when multiplying complex numbers, the exact same thing, right? So we do like we would in algebra, but if we come across an I squared, we change that to a minus 1 like we saw in the last video. So, given that I squared is equal to minus 1, so they always usually like to tell you that little tidbit there, it's very important. Simplify this, 4 plus 2i times 3 minus I. So, what do we do here? These are distribution properties, so 4 times this bracket, so 4 times 3 minus I, plus 2i times 3 minus I. 4 times 3 is 12, 4 times minus I is minus 4i. 2i plus 3 is plus 6i. 2i times minus I is going to be plus. Sorry. So 2i times minus I, that's going to be minus 2i squared. Now we notice here I have an I squared, so we have to be careful and change that to a minus 1. So I'm going to have 12 minus 4i plus 6i, it's going to be plus 2i. Minus 2 times minus 1. 12 plus 2i is plus 2. So I'm going to get 14 plus 2i. And that is me multiplying and solving out a complex number. So it's actually very straightforward. So let's just look at some exam questions here. Well, would you believe? The first one, I already did it. So cross that out. I must have typed it in wrong. Right. Let's look at this one. This is from the year 2000. God, right? I've been to the year 2000. Much has changed, but they live underwater. Right. Simplify 7 times 2 plus I times 11 plus 9i. Give your answer in the form x plus yi, so or a plus bi. So that's another way of writing that. So 7 times 2 is 14. Then 7 times I is 7i. I times 11 is 11i. I times 9i is plus 9i squared. Again, I squared I have here, I make that a minus 1. So I have 14. 7i plus 11i is plus 18i. Plus 9 times minus 1. 14 times 9 plus 9 minus 1, that's going to be a minus 9. So 14 minus 9 is 5. And then plus 18i. Bada boom, bada bing. Let's look at some more. Let w equal 3 minus I. Evaluate w plus 6i. Well, that's very easy. So w is equal to this. So 3 minus I. Then add 6i. gather my i's. 3 minus I plus 6i is 3 plus 5i. Easy peasy lemon squeezy. Next one, let z equal 2 plus 4i. Express z squared plus 28 in the form p plus qi. So this just means a plus bi, so a real part and an imaginary part. So that's going to be 2 plus 4i squared plus 28. So it's going to be 2 plus 4i times 2 plus 4i plus 28. 2 times 2 is 4. 2 times 4i is 8i. 4i times 2 is plus 8i. 4i times 4i is plus 16i squared. Right? So I times I is I squared. That is going to go to a minus 1. So I'm going to have 4 plus 8i plus 8i is 16i. 16i squared is going to be 16 times minus 1. So 4 plus 16i minus 16 is going to be minus 12 plus 16i. There's our answer there. Let's look at the final question here now I have. So 2011, the Leaving Cert Ordinal Level, this is from paper 1, question 4a. So z is a complex number 1 plus I, where I squared is equal to minus 1. So find z squared and z cubed. So z is equal to 1 plus I. Let's find z squared. Well, that will be 1 plus I times 1 plus I. 1 times 1 is 1. 1 times I is I. I times 1 is I. I times I is I squared. And I have an I squared, so that's going to go to minus 1. So I'm going to have here 1 plus 2i minus 1. And that's just going to give me 2i. There you go. So z squared equals 2i. Z cubed. Well, instead of multiplying the bracket 3 times, I know z cubed is equal to z to the power of 2 times z to the power of 1. So that would be equal to 2i times 1 plus I. Multiply it in. 2i times 1 is 2i. 2i times I is 2i squared. That's going to be 2i plus 2 times minus 1. The answer is minus 2 plus 2i. That is equal to z to the power of 3. So, part 1 done. Part 2 is telling me verify z to the power of 4 is equal to minus 4. So, what we could do here is, I know z4 is equal to z cubed times z to the power of 1. Or, the more easier option here is that's the same as z to the power of 2 times z to the power of 2. Or just z squared all to be squared, which is 2i all to be squared. And then if I have 2 something squared, 2i squared, that's going to be 2 squared, which is 4i squared, which is 4 times minus 1, which gives me minus 4. So therefore, z to the power of 4 equals minus 1. Right, so we've done them questions there. Hope this video was some help. Nice and short, easy peasy lemon squeezy. And we're going to do division in the next video. And I'll catch you guys later. Bye.